something to write with in front of them? Well, binder paper, something to write notes on. Something to write notes on. Okay. What? The warm-up was meant to finish that last question from yesterday. Yeah. Today we're talking about conic sections. And they are called conic sections because these four shapes are produced when a plane intersects a double cone. I'm going to stop with the first half of that definition. In math, what is a plane? It's not the thing that flies, because this is not like engineering class. I see people doing this. I see people saying a map. Good. It's a flat surface, yeah? Like a piece of paper, but it extends forever and ever, right? So this is just a flat surface that extends in all four directions forever and ever, right? Flat. It's a plane, goes forever. And we get conic sections when that perfectly flat plane intersects, which is why it's called a section, a double cone. Thus, the conic part of conic sections. We're talking about cone. The question is, what does a double cone look like? We know what a cone looks like. Looks like a birthday hat, yeah? A double cone is if I took two birthday hats and I put the pointy ends together and I taped them together. And this is where I'm going to ask you to bear with my horrible drawing. Double cone. Two birthday hats, pointy ends together, tape them. Double cone. Double cone. Again, horrible drawing skills, that's why I'm not an artist. Did you get the idea, yeah? And there's only four possible options when we take our plane and we put it through the cone. So we're going to look at all four possible shapes, and then we're going to look at their properties. Yeah? And I'm going to start with the one that we saw way earlier in this semester, way back towards the beginning, which is a circle. We can have circles. Maybe, if my... There we go. No, we don't want to crash. No crashing. I don't care. No, wait. What? Get rid of that. There we go. You do not have to draw that particular image, but that's to help you visualize what's going on. So that's us taking our double cone. That's the stuff that's shaded in green. Our double cone is vertical. Our plane is perfectly horizontal. And because a cone is circular in shape, when I do a cross section like that, I get a circle. The intersection, the point where the plane touches the cone, traces the circle. Yeah? That's the first possible shape. If I take this orange plane and I tilt it upward just a little bit, what happens to that shape of intersection? It's no longer a circle. If I tilt it, what do I think I'm going to get? An oval. Yeah, and in math, we don't call it an oval. What do we call it? Call it an ellipse. An ellipse. We call it an ellipse, but you are right. It produces an oval instead of a circle. Yes, Emiliano? What? No. You don't have to draw that. You might want to draw just that little circle or that little shape. You don't have to draw the cone in the intersection. That's just to help you visualize. Yeah. I do not expect that you are 3D drawing experts. That is hard. Halfway done. So the two figures we've drawn so far are closed figures. I can take my pencil, I start tracing an ellipse. Eventually my pencil is going to end up back where it started. Forms a closed shape. If I take that orange plane and I tilt it so that it's parallel to the side of the cone, we get a new shape. And it's one you saw in Math 2. What did you spend the whole first semester of Math 2 looking at? You forgot it starts with a P. Parabolas. Quadratic equations produce parabolas. Parabolas are a conic section. And you'll notice in my drawing, you don't need to draw the conic section. You just need to draw the little blue shape. You'll notice that they indicate the tilt of that orange plane is parallel to the tilt of the side of the cone. So like circles, parabolas are very specific. The plane has to be oriented exactly parallel to the side of the cone. And you'll notice we only get one parabola. It intersects down here, but because it's parallel, it won't intersect up here. So parabolas come in single use. If I take that orange plane and I continue tilting it upward, what's eventually going to happen? I have a plane like this. How many curves do I get? If my plane intersects like that, how many curves do I get? 2. Because I'm going to get a curve down here, I'm going to get a curve up here. Yeah, so the next shape that we get has 2 pieces, 2 opposite facing U's, and it's called a hyperbola. Hyperbola. And with hyperbolas, the 2 curves will always face away from each other. Sometimes they're up and down U shapes. Sometimes they're side to side U shapes, but they always open opposite each other. Their vertices are towards each other. Because all of these shapes are coming from intersections with a cone, all of their equations are going to look very similar. The patterns will be very similar. And so what we're going to practice today is making connections between the shape and the patterns in the equation. And we'll go in the order that we presented them here. So we're going to start with circles, because ideally we've seen them before. Let's see if we can use technology to make a prettier graph than I can draw by hand. Okay, so we have a circle. Circles have two important properties. They have a center of the circle. Center, yes. And then how do I define how wide or narrow the circle is? Radius, yeah. We can use radius or diameter, but mathematicians prefer radius. Radius goes from the center to an outside edge. Yeah. What letter do we use to represent radius? R. Radius equals R. Center is a point in the coordinate plane, meaning it has two pieces, an x and a y, and we usually represent it as h, comma, k. Give me a thumbs up if you remember seeing those letters earlier this semester. I see a couple thumbs up popping around the room. H and K are those letters that we use to take a function and slide it around the coordinate plane. H moves it side to side, K moves it up and down. So our default circle starts at the origin, its center is at 0, 0. H and K then move that center side to side and up and down. Good, good. The formula for a circle, formula not function, is x minus h squared plus y minus k squared equals r squared. And I hear a what? That looks a little bit like the Pythagorean theorem, a squared plus b squared equals c squared. And it's coming from the triangle that it results from comparing a point on the circle to the center. And if I trace that point around the outside edge, I'm doing a bunch of right triangle calculations. So that is coming from Pythagoras himself. Yay, words are hard today. A couple of things to notice. Yes? This formula has no fractions. That's important. Come on, pen. Some of the conic sections that we're going to see later will have fractions in them. You'll see the x minus h squared over a number. Circles will not have that. Circles, it's x squared plus y squared equals a number squared. The other thing to notice, this is an addition problem. Some of our conic sections will have subtraction between the two terms. So another way I can recognize circle. No fractions, addition between the x and y terms. And the third thing that identifies it as a circle is that both the x term and y term are squared. Both x and y are squared. So what we're going to do with our information about a circle and its standard form equation is we're going to practice picking information out of the equation to describe the circle. What is its radius? Where is its center? We're going to practice picking information off a graph to write the equation for the circle. We should be able to move back and forth between equation and graph. That's the goal. I see some nodding. Yeah. All right. Are we ready for some examples? Yes, good. So I want to find the center and the radius for my circle. And the standard form equation for this circle is x minus 2 squared plus y minus 1 squared equals 9. So I know that the three important numbers, one is attached to x, one is attached to y. Those are the coordinates of my center. The number on the other side by itself is my radius squared. So I know this thing here is h, this thing here is k, this thing here is r squared. Are you okay with that so far? Matches the standard form equation, good. So we'll start with our center. Who can tell me the coordinates of my center? Numbers. I'll give you a hint, I underline them. 2, 1, yeah. Notice I'm recording them as positive because the negatives are built into the standard form equation. Anything that's attached to the variable itself, the negative's built in. You have to change its sign. Right? We've seen that with every transformation we've done. It's attached to the variable, it changes sign when we pull it out. Yeah. And then the radius. I know r squared is 9. How do I find r? Better question. How do I undo a square? Square root. Perfect. So this should be the square root of 9, which is 3. Perfect. I now have enough information to graph this circle. So I'm going to do that really quick. So I know my center, that's where I'm going to start, is at 2, 1. So over 2, up 1, that's my center. And I know I have a radius of 3. And what I do is I choose 4 directions and make a dot 3 points away, up, down, left, right. And it should be 3 squares away from my center. So I'm going to go 3 to the right and 3 to the left. I'm going to go 3 up and 3 down. 1, 2, 3. So those 4 points should sit on my circle. And then I'm just going to use my pencil and try and draw a smooth curve. I'm going to cheat because I can do it that way. Not cheating. It's called using appropriate technology. My center is at 2, 1. I went out 3 in either direction. Nice smooth curve. Yeah? If you're asked to graph a circle in Delta Math, that's how they want you to do it. Mark your anchor points and then just expand the circle out so they cross through those anchor points. Good. Let's try another one. Put your phone away, child. Brownie face. Hmm? We want to find the center and radius for the standard form circle. X plus 1 squared plus y minus 4 squared equals 16. And I know I'm identifying three numbers, the thing attached to the x, thing attached to the y, the thing by itself. H, K, R squared. We start with the center. Can I get a volunteer? Who can tell me where the center of this circle is? Ziza has a hand up. What do you say, Ziza? Negative 1, 4. Ellie, do you agree? Very good. If it's positive in the equation, it becomes negative when we pull it out. Anything attached to the variable changes sign. Good. And then the radius. Cecil. 4. How'd you get 4? Perfect. Square root of the constant. Happy face. Happy face. Very good. I'd make my center at negative 1, 4. I'd go 4 out in either direction. I'd connect the dots. Yeah? Reasonable? Doable? Good. Let's practice going the other direction. Yes, it's good for you. So now I have graphs of a circle. I want to write their standard form equation. And I know that means identifying the same three numbers that I was just picking out of the equation to make the graph. I need H and K for the center. I need R so I can figure out what R squared is for the constant on the right side. H and K should be straightforward because you should always be shown where the center of the circle is. Sometimes they're going to be mean, as you're in college math class now, and they'll give you the points on the edge, but not the point in the center. So if I didn't know that this was at 2, 2, how could I figure out that it was at 2, 2? And the answer, yes, Cecil. Okay, what do we do with those two outside points? Put them together how? What am I going to do? You're on the right track. We need to deal with adding numbers. But if I look at where those points are, they're on the same height as the center. So I don't think I want to touch the y's, because I know y is a measure of height. So I know my y coordinate is 2, because the other 2 points are at a y coordinate of 2. They're all at the same height. It's the x coordinate. Where does it sit side to side that I need to figure out? And I know my center should be halfway between the edges. So the question is, what number is halfway between -1 and 5? So if I look at that distance, -1 to 5 is 6 boxes. What's half of 6? 3. So I'm going to go from the edge, and I'm going to go 3 forward. So 6 divided by 2 is 3. I'm going to start here and go 1, 2, 3. So this is 0, 1, 2. Puts me at 2. So even if they didn't give me the center, as long as I've got points on opposite sides, my center is halfway between. Halfway between -1 and 5 is 2. Halfway between 2 and 2 is 2. Good. So H and K are 2 and 2. What's my radius? Give you a hint. We just found it. 3. Distance from the center to the outside edge. Yeah, good. Once I have those 3 numbers, now I'm substituting them in to the standard form equation. Standard form is x minus h squared plus y minus k squared equals radius squared. 3 squared is what? 9. The equation for that circle is x minus 2 squared plus y minus 2 squared equals 9. Yeah, perfect. Happy face. Thumbs up, sideways, thumbs down. How do we feel about circles? I see mostly thumbs up. Circles, pretty straightforward. Ideally review. Good. Good. We're going to look at the next shape, which is I take that plane and I tilt it a little bit so I get an oval instead of a circle. And what do we call those ovals? Ellipses, yes. Very good. Oh, the art class is at it again. Okay, so ellipses come in 2 flavors. My oval can be a tall oval, or it can be a long, flat oval. So with ellipses, I have to consider both cases. My ellipse can look like this. Oh, that is a horrible ellipse, Mr. J. Or like this. Hey, Sadie, what's up? Not at all. What are you going to do? Perfect. Okay. Fuego on the shelf. Fuego on the shelf. Looks like a Woody on a horse. Okay, where am I going?
We're just gonna pose right now.
And then we're gonna do like everyone doing notes and stuff.
Yeah,
Okay.
and then we're gonna take pictures in the classroom, but that's fine.
That is perfect.
Okay. Ready? 1, 2. All right. Thank you.
And then you can go back to the TTS.
Perfect. Thank you. All right. Our ellipses are related to circles, right? They're conic sections. We shoved a plane through a cone. So like circles, these guys have a center. I didn't draw too well, but they have a center, yeah? Any guess what letters we're going to use to represent the coordinates of a center? H and K, gold star. The assumption is they start at the origin. If we move them from the origin, H and K. Good. Perfect. Now I run into a problem. Circles have the same width all the way around. Single radius. Ellipses have two different lengths. One tall side and one short side. So we get what's called a major axis and a minor axis. So the major axis is the long side. And then we get a minor axis through the short side. Notice they are passing through the center. Those axes behave like the diameter of a circle. They go all the way from edge to edge, one through the long side, one through the short side. And the question is, how do I incorporate that into my equation to represent that closed shape? So this is going to look really similar to the equation for a circle because it's still a closed shape. So how did the standard form equation for my circle start? Who remembers? X minus h squared. Y minus k squared. Good, that's what's giving us that closed shape, and then it had equals a number. Perfect. So ellipses are going to look similar. And the question is, how do I account for the fact that now I don't have a uniform width all the way around? The uniform width all the way around showed up as the constant on the right side of the equation. Yeah? To account for the fact that now I have two different distances, I'm going to have a 1 over here. And the different lengths, the wide side and the narrow side, are going to show up underneath those variables. And they show up as an a squared and a b squared. And a squared and b squared are half of those axes, the major and minor axes. So in this first graph, my a is the distance from the center to the, right edge. B is the distance from the center to the top edge. Same thing in the other picture. A is from the center to the outside edge on the x-axis. B is from the center to the outside edge on the y-axis. A goes with x, B goes with y. A goes with x, B goes with y. Yes. Yes. B is looking at that half length for the vertical. A is looking at the half length for the horizontal. Good. And the letters are paired with the variables that their axis lies along. Yeah. And then the other question is, how do I tell, looking at that standard form equation, whether it's a tall ellipse or a long ellipse? And the answer is I look for where the bigger number is. The bigger the number, whichever one of those numbers is bigger, that's my major axis. That's the long axis. Thank you. So if A is bigger, the x-axis is the wider side. It's a long, flat ellipse. If the bigger number's underneath the y is the major axis. It's a tall ellipse. So for ellipses, I'm looking, where's the bigger number? That's the longer side of my ellipse. If it's underneath the x, x is long. If it's underneath the y, y is long. So we're going to do the same thing that we did for circles. We're going to identify A, B, and the center. And then we're going to practice graphing from those. And then we're going to identify A, B, and the center from a graph. Yeah? Deep breath. Oh, and I should circle that because this is my standard form. Yeah. Happy face. And I think we'll do hyperbolas on Friday. I don't think we'll get to those today. The next one will be fast because we've seen the next shape before. I can do that. I don't want to stress you guys out too much. All right. So let's do our first one. The first question is, how do I know that that's an ellipse? What about the numbers? Ooh, good. So I know it's an ellipse because the denominators, right, there are fractions and the denominators are unequal. Other than that, it looks like a circle. It's addition. Both x and y are squared. It's important to remember that when you see addition, that's an ellipse because hyperbolas are going to look very similar to ellipses, except they have subtraction between their terms. So ellipse is addition, hyperbola is going to be subtraction. Happy face. Good. We have more numbers floating around. So how do I figure out where my center is? Can I get somebody who hasn't spoken yet? Raise your hand. Who sees the center? Emiliano, what do you see? 1 and 2. 1 and -2. Can I get a thumbs up if you agree with the 1 and -2? Very good. H and K change sign when we pull them out. Very good. I need A. I need B. A and B. A and B. Vicky, what is the value of A? 4. Are we sure? 2. Very good. It's x squared over a squared. Y squared over b squared. So square root of 4 is 2. If I could get my pen to work. 2. Ethan, what is my b? First question, how did I get from 4 to 2? How do I get from a squared to a? Good, there you go, 3. Yeah, 9 square root is 3. Perfect, perfect. So get from a squared to a, b squared to b, we square root. Good. I have enough information to graph. I can graph. The idea to plot this is similar to circles. I'm going to mark my center first, and then I'm going to go points on either side, left and right, up and down. Before I do that, I want you to take about 60 seconds, maybe a little less in your small groups, and discuss, is this a short, wide ellipse or a tall, skinny ellipse? Make sure you can explain how you know. Discuss with your table. Short and wide, tall and skinny. Short and wide, tall and skinny. How do you know? Jesus is on fire today. I like your reason. So, which one? Which of the constants is bigger, A or B? B. Does B go with X or Y? Y. B and Y are paired up. So the Y-axis is longer. It's one of those. Good. All right, Jesus. What did your table decide? Short and wide or tall and skinny? Tall and skinny. How did you know it was tall and skinny? Very good. We look where the bigger number is. Bigger number was with Y. The Y-axis is going to be the longer axis. That's our major axis. Good. So major axis is Y. Minor axis is X. Good. We're going to plot our points. I'm going to do that in a different color. So my center is at 1, -2. That's my center. And then I'm going to do the 4 points in either direction. A goes with X. B goes with Y. So on the X-axis, X direction, I'm going out 2 in either direction. On the Y-axis, I'm going out 3 in either direction. So for X, I go 2 forward. Yes? Yes, it is. Thank you. I am glad somebody is paying attention to my nonsense. 1, down 2. There we go. I did it backwards. Good. Right 2, left 2. Right 2, left 2. Up 3, down 3. Up 3, down 3. And then you grab your pencil and you do your best to make a pretty egg. Yeah? Good. We're going to try another one. I'm going to have you do it on your own, and then I'm going to have a group come up and draw it for us. Because it's good for you. All right, give you about 3 minutes. Figure out where your center, your A and B are. Graph your ellipse. What's being added or subtracted to the x? It's not 1. Is there a minus h there? No, if it's missing, what is it? 0. Yeah. If he's doing that during lecture and not doing it all, you don't have to give him your notes. That's on him. You're a big boy. You're choosing to be lazy right now. That is a choice. There is a box right there that I have left out because I know that I've been asking you to do notes on your own. You have 2 legs. You can watch up and get some. You want to be an adult, you got to handle your own shit.
So does this turn to a 1 or is it just 0?
So if we compare that to this, do we see a minus anything after the x? No. So what would that be if it's missing entirely?
0?
Yeah.
Oh,
Good. Mm-hmm. Self-medicating because I have ADHD. It helps calm my brain down.
Is it the sweetness that gets you?
I like the sugar, but it's the caffeine that activates my prefrontal cortex, which doesn't work properly because of the ADHD.
So do you like sweets?
I do.
Do you like sweets from Mexico?
I'm not familiar with lots of sweets from Mexico, but I like sweets in general.
Well, I thought about you while I was in Mexico, and I'm like, you know what?
Aww.
Charlotte needs the sweets, you know?
Thank you. Heck
Those
yeah,
look the
I
most
love sweets.
Sweet-looking sweets.
Thank you. That was very kind of you. I appreciate that. No, if that's all it took, I'd be a lot bigger than I am right now. Yes. Yeah. I know a couple groups are done. So if I compare this to the original standard form, the default standard form for ellipses, I see x minus a number. Is there a minus a number here? So if it's missing entirely, what is it? Yeah, there you go. Mm-hmm. Got it? Hey, Vicky said yes. Have Vicky and Alexis talked? Yeah. Okay, good. It's a wonderful ellipse. We're working on our ellipse. Very good. No crying. Why are we crying?
During college acceptance time.
Oh.
I'm just not gonna announce it. I'm just gonna eat it.
If it makes you feel better, I did not get into any of my first choices, neither as an undergrad or a grad student, and my life turned out just fine.
I'm looking forward to get rejected because I'm going to Uber Eats food.
I'm looking
Yeah.
forward to not going to any of the schools I got accepted into and go straight to Hartnell because I want to go to Chicago.
That's fair. I spent a couple of years at Hartnell before I transferred to Fresno State. And then I did my undergrad at Fresno State and did grad school at a UC. All right, let's pick a random person. Put that phone away. See who our person is going to be. Luna. All right, Luna. Luna has the center of 0, 0. Good. 2 is A. 4 for B. Vertical, so it's a tall, narrow guy. Okay. How did you graph it? What did you do? Can you walk me through the process? Point at 0. Up 4. Down 4. Left 2. I kind of know what left is. All right, can I get a thumbs up if we agree with Luna? Very good. Very good. Major axis is along the Y. Minor axis is along the X. Center at 0, 0 because H and K were missing. Perfect. Now the question is, can we go backwards? No crying in math class. Yes. You think you what? How what? He did. Yeah, Gene was first. So I remove as we go, and then it resets for next time. Oh, come on, pen. All right. We want to write the standard form equation for the ellipse shown in the graph, and we're given 4 points. 2 along the y direction, 2 along the x direction. So I suspect they're giving me major and minor axes. Major axis is this way, minor axis is this way. I need 3 numbers to write my equation. I need my center coordinates. I need A. I need B. So let's start with A and B. I think those will be a little faster. A and B. 2 and 2 is 4. 4 and 2 is 6. 6 and 2 is 8. 8 and 2 is 12. 12 and 2 is 16. 16 and 2 is 18. 18 and 2 is 20. 20 and 2 is 21. 21 and 2 is 22. 22 and 2 is 23. 23 and 2 is 24. 24 and 2 is 25. 25 and 2 is 26. 26 and 2 is 27. 27 and 2 is 28. 28 and 2 is 29. 29 and 2 is 30. 30 and 2 is 31. 31 and 2 is 32. 32 and 2 is 33. 33 and 2 is 34. 34 and 2 is 35. 35 and 2 is 36. 36 and 2 is 37. 37 and 2 is 38. 38 and 2 is 39. 39 and 2 is 40. 40 and 2 is 41. 41 and 2 is 42. 42 and 2 is 43. 43 and 2 is 44. 44 and 2 is 45. 45 and 2 is 46. Show of hands, who knows how to find A? Similar to how we found the center and the radius for our circle. How do I find A? A is the horizontal, B is the vertical. So what is the distance from this point here to this point here? It's 10. What do I do with it to find A? Just like I did with the diameter to get the radius. Yeah. So A must be 5 without drawing on the picture. What's my B? 2. Half of 4 is 2. It goes from 0 to 4. Good. Perfect. Now I need to know where my center is. And Ziza's mumbling something, but I don't know what it is. Ziza, what are you thinking? I have a vote for 0, 2. How did you get 0, 2? Very good. So when we look along the x direction, we look at the x coordinates. Halfway between -5 and 5 is 0. Gave us 0. Good. Along the y direction, we look at the y coordinates here along the minor axis. Halfway between 0 and 4 is 2. The center should be right smack in the middle. Yeah, perfect. Happy face. Now I have to write my equation. X minus h squared over a squared plus y minus b, or not b, k squared over b squared equals 1. I think I did that correctly. I see some nodding. Good. And I'm going to simplify. What is x minus 0? This is x squared. Yeah, good. So I get x squared over 25 plus y minus 2 squared over 4 equals 1. Yeah. That's... You were going straight for the, yeah, you figured out the length and squared it ahead of time. Good. Good. Perfect. So delta math, very similar. Sometimes they'll give you a picture, ask for the equation. Sometimes they'll give you an equation, ask for the details. Good. We're going to do one more today really quick because we're not going to spend a lot of time on it because you've seen it before. What was the third of our 4 shapes? Parabolas. We saw those earlier in like unit 2. You saw them like half of math 2. We know what parabolas are. I can't spell them apparently, but we know what they are. And the question is, what does the equation for a parabola look like? And I don't know why the book does this backwards. So parabolas come in 2 different shapes, just like ellipses do. I can have happy faces and frowny faces, vertical parabolas, which are proper functions, or I can have sideways parabolas, either opening to the left or opening to the right. Those are not functions because they don't pass the vertical line test. Most conic sections are not going to pass the vertical line test. Good. So we have 2 options. We have one of these or one of these. And the question is, what do equations that graph parabolas look like? What do we call them? It starts with a Q. Quadratics. Can somebody give me an example of a quadratic function? Y equals x squared. Yeah. This guy, on his side, what do we think he would look like? We switch the position of x and y, so we switch the position of their variables. I'm going to give the general form in just a minute, but the thing to notice about parabolas that's going to differentiate it from all of the other conic sections is parabolas only have one of their variables squared. Parabolas only have one variable squared. Please, guys, no. Please, guys, no. We're going to do something a little bit different than the textbook does, because I want to follow the same pattern that we've been using for circles and ellipses. So I'm going to give it in vertex form, because that mimics standard form for circles and ellipses. And I'm only doing vertex form for the vertical guys. It gets a little weirder when it's a horizontal. And then I'll show you the standard forms that your book does. Way back in Math 2, you learned vertex form, which is y equals x minus h squared plus k. We liked vertex form because it told us where the vertex of the parabola was. You probably saw it with an A out in front. That dictated whether it was a happy face or a frowny face. If it was positive, it was a happy face. If it was negative, it was a frowny face. And I see some nodding. So that is the first form we learned. Very similar to what we saw for ellipses and circles. Instead of a center, it's got a vertex, but it still has an h and a k. It still has a constant that tells me whether it's narrow or wide, which is why we like vertex form. I think I just approved it, did I not? I did. Check your own pass. Okay. Standard form looks a little bit different. Parabolas don't have a center in the same way that our closed figures do. And so standard form is going to look a little bit weirder. Similar idea. We know if it's up and down, a happy face, frowny face, it's y and an x squared. If it's a side-to-side parabola, it's x equals y squared. But we're going to introduce some new letters here. Oh, I hate the way they do this, but that's okay. And I see frowny faces, and you should see frowny faces because we don't usually write equations like that. That looks really weird. We've isolated the squared and not the variable without an exponent, which seems backwards to us. But remember, just like here, if the x is squared, it's a happy or frowny face. If the y is squared, it's on its side. And the question is, what the heck is that p floating around? So I'm going to draw a picture of a parabola for each of those, and we're going to look at what that p is showing us about the parabola. And I'm going to ask that you be patient with my absolutely horrible drawing. That's not so bad. I'll take that one. Children, play nice. So x squared, we have happy face, frowny face. Y squared, we have sideways parabola. There are two things that parabolas have that define its shape. The first, I'm going to do in red, and it's called a focus. And it sits just inside the parabola, above or to the side of the vertex. I can see my parabola is bending around the focus. The other thing that a parabola has is called a directrix. Fun math word. I don't know what crazy mathematician made up that word. I am sorry, it was not me. And that is a line on the opposite side of the focus. So for this first picture, my happy face parabola, my focus is above the parabola. My directrix is the same distance below it. So my directrix is going to pass through here. Make sure I spelled that correctly. Yes, I know. Yes, I did. I know how to spell. Don't judge me. Why a directrix? Here is the answer. That shape is defined by the relationship between the points on the curve and where they are relative to the focus and that line. So if I pick a point here on my parabola and I draw a line from that point on the curve to the focus, and I also drop a line from that point down to the directrix, straight down, nice perpendicular line. Those two distances are equal. And they are equal for every point on the curve. That is what defines its shape. P is telling us where that focus and directrix are. P is the distance from the vertex to the focus. That's P. P is the distance from the vertex down to the directrix. P is telling me how far that vertex is from those 2 points that define the shape. I'm not going to ask you to do that on your final. This is not showing up on your final, but I want you to see it if you have to take calculus again. Yeah? All right. Question is, what does that look like for the horizontal guy? So where is my directrix going to sit on that sideways parabola? Behind it. Good. So this was 2 in front. This is probably about 2 behind. Horizontal line, vertical line. Vertical line. Good. Because this is a horizontal parabola. Directrix is always perpendicular to the axis of the parabola. Good. And this is that same pattern. Distance from the vertex to the focus is P. Distance from the focus to the directrix is P. If I can pick off P, I can write my equation. Yeah. Okay. Yeah, that was a lot. That was a lot of information, right? Okay. On Delta Math, you have 2 pieces of problems. Some are on sequence from the first half of our lessons. Some are going to be on Conic Sections, which is the second half of this week. You have enough information to get through like 80% of the homework. You've got about 20 minutes of class time to work on it. So please get your Chromebook out. Make sure that you're using class time wisely. Get a head start on that Delta Math, because this Delta Math is our last homework assignment, proper homework assignment of the semester. Next week is finals review, and we got our finals.